All right, so let's solve a problem which appeared in JMA in 2025. This is a question from vectors, and what has been asked here is to find the value of alpha plus 2 beta plus 5 gamma, where some other information is provided that there is a triangle with the position vector of the vertices as given here, and then the position vectors of the orthocenter and circumcenter of the triangle are also given. Then we are supposed to find out the value of alpha plus 2 beta plus 5 gamma. Okay, so I mean there is a triangle, and then the vertices of the triangles are given the position vectors. So let's say this is 4p plus q minus 3r, and then another vertex is 5p plus q plus 2r, and then another vertex is 2p minus q plus 2r. Now what else is also given is that there is this orthocenter and circumcenter's position vector. So somewhere there will be orthocenter, then somewhere there will be a circumcenter, and then um, in between there will be a centroid as well. And this is what is the property which we should be always looking for. Whenever something related to orthocenter and circumcenter is given, then we try to look at the centroid. If centroid and orthocenter is given, we try to find out the circumcenter and try to make use of a property which we already know, right? So the property is like this, and this is what we should be trying to use here. That if you've got your orthocenter and then centroid and circumcenter, right? They get divided by the centroid into 2:1 ratio. So we have been given this and this, but it's not given this. So we'll try to find out our centroid, and centroid would be simply the position vector, all these three vectors, and then by 3. So you can sum up all these position vectors. So 4p plus 2p minus 5p. So let's write it out. So 4p, I'm just trying to get the components individually. So 2p minus 5p together, and then q minus q and plus q, and then minus 3r plus 2r plus 2r, and then divided by 3. So this is what will be the position vector of it. So you can say this is OG, and this is what it is. OG is going to be given by this, which will be 4 plus 2 is 6. 6 minus 1 is 1. So P. Q and Q get cancelled. This is Q, and then this is R. So we got our centroid as P plus Q plus R by 3. We've also got our orthocenter and our circumcenter. So we make use of this, the section formula, to arrive at this using the information of H and C. So 2 times the value of circumcenter here, 2 times alpha P plus beta Q plus gamma R plus 1 time P plus Q plus R divided by 3 should be equal to the centroid. So this will be P plus Q plus R by 3. Now 3 gets cancelled, and then we can separate out the P's. So this will become 2 alpha plus 1 time P plus 2 times beta plus 1 time Q, and then 2 times gamma plus, 2 times gamma, 2 times gamma plus 1 R, right, equals to, we will have this P plus Q plus R, right, by 3 here. P plus Q plus R by 3. Oh, not 3. So 3 is cancelled, right? So yeah, so from here, this is what you will have, right? So if you've got this one right, I think the idea is that alpha P plus beta Q plus gamma R, and this is 2:1. So from here, what you get is alpha is 2 alpha equals to, so what you get from here is 2 alpha. Okay. So I think the problem here is that this part is not p plus q plus r, but rather this is p plus q plus r by 4, right? Yeah, so that is what it is. Then here what you will have is p plus q plus r by 4, right? So then this nothing changes much, but here this will become 1 by 4, this will become 1 by 4, this will become 1 by 4. And now you compare both sides, right? With this p, coefficient of p, because both of these are equal, right? So you can say that 2 alpha plus 1 by 4 is actually equal to 1. 2 beta plus 1 by 4 is actually equal to 1. And then 2 gamma plus, come on. So this is 2 gamma plus 1 by 4 is actually equal to 1. So from here, what we get is 2 alpha equals to 1 minus 1 by 4, which is 3 by 4. So alpha is going to be 3 by 8. Similarly, beta is also going to be 3 by 8. And gamma is also going to be 3 by 8. Right, so all of these values are 3 by 8, but we are supposed to find out alpha plus 2 beta plus 5 gamma. So alpha plus 2 beta plus 5 gamma. So this will be 3 by 8. Then this 2 times beta will be 6 by 8. And then 5 times gamma will be 15 by 8. When I sum it up, 15 plus 6 is 21, 21 plus 3 is 24. So 24 by 8 would make it 3, right? So this is what will be my answer? 3, right? So this is the answer here, all right? So if you try to solve it in any other way, you will actually end up with a lot of problems. Like if you think that, okay, this is a circumcenter, then maybe it is going to pass through, it will be a perpendicular bisector to it. So you will find out maybe a point over here, this is a midpoint, and try using this. And again, same way for this Orthocenter also, you can try writing a vector which will be passing like this. You can do that, but it will become a little bit complicated and you might not find it so easy if you had just used this a property, which is like the centroid is dividing the orthocenter and circumcenter into 2:1 ratio. So if you use this, then this problem is pretty easy. And this property has been used quite a lot in previous JMNs as well. So you might be knowing this property. All right. So that's all about this question. If you got any queries, do ask me in the comment section below, and I'll be happy to answer your queries. Thank you so much for watching this video. Have a good day.